You type a complex question into an AI, and seconds later, it delivers a polished explanation. You read it, and it makes perfect sense. Psychologists call this the illusion of explanatory depth. Because the machine's output is so fluent, your brain tricks itself into believing that you understand the topic just as clearly. But the moment you close the laptop and try to explain that same concept to someone else, you draw a blank. The knowledge vanishes. Encountering a clear explanation generates a feeling of familiarity. That sensation is distinct from building a durable memory, which requires specific mental moves that passive reading simply bypasses. This friction-free interaction is the answer machine model. It feels productive because it provides immediate results, but it leaves your cognitive architecture unchanged. To bridge the gap between reading and remembering, we have to simulate the behavior of active tutoring. A tutor doesn't just provide the answer, they force the student to organize, retrieve, and apply the logic. We can operationalize this through the AI Tutor Loop. This framework breaks the learning process into 5 specific prompts: map, model, recall, repair, and transfer. Each stage is designed to trigger a specific cognitive requirement, turning the AI from a source of information into a tool for training your brain. We'll use the example of learning compound interest. Step 1 is the map. Because human working memory is limited, we have the AI build a structural mental map of the prerequisites before we dive into the math. We prompt the AI for this structure. Create a beginner learning map for compound interest, showing the relationship between principle, time, and exponential growth. With the map in place, we move to step 2, model. Here, we shift the focus from obtaining a final answer to observing how an expert navigates the reasoning process. We command the AI to think aloud through an example, using an analogy, like a snowball rolling down a hill, to explain the logic behind every decision in the calculation. Mapping and modeling create the necessary mental scaffolding. They prepare you to attempt the skill, but the actual practice happens in the next stage. Step 3, recall, removes the source material. Actual learning begins the moment you have to produce the information without looking at the screen. You tell the AI, hide previous answers and quiz me on compound interest one question at a time. Do not show me the answer until I respond. This forces your brain to retrieve the concept, which strengthens the neural path. Errors will naturally occur during retrieval. Step 4, repair, uses those errors as diagnostic data to fix gaps in your understanding. The prompt is, here is my answer. Diagnose what I misunderstood, explain the error, and give me one targeted practice question. This forces you to reconcile your mistake with the correct logic. The biological mechanism of retention is driven by this struggle to remember, followed by immediate targeted correction. Step 5, transfer, proves that your brain has abstracted the underlying rule. It confirms you haven't just memorized a definition, but can use the logic in the wild. This requires non-isomorphic transfer. The core logic remains the same, but the context is completely swapped out. We prompt the AI, shift the logic of compound interest from a wealth-building scenario to a credit card debt scenario. The AI asks you what move you would make first, forcing you to adapt your reasoning to the constraints of a financial penalty rather than a reward. If your reasoning fails when the context changes, the learning is still fragile. You simply return to the map and begin the loop again. Map, model, recall, repair, and transfer. These stages form a continuous engine for building skill through repetition and feedback. In this framework, the initial AI explanation serves as the foundation for the steps that follow. It is the starting material, not the conclusion. This method requires more effort than reading a summary. It is built around cognitive friction, which can feel frustrating in the moment. The next time you face a difficult topic, look past the quick answer. Ask the AI for the loop. AI functions as a tutor once we engineer the interaction to provide the exact mental work where true learning happens.